Alrighty here, so for these first couple problems, we're just simply writing an inequality to describe the number lines. If you notice, this first one has an open circle on -5 and is going to the right. So this would say that x is greater than -5 because it's all the numbers bigger than -5, and it's greater than because it's an open circle. The next one is a closed circle at 11. And we're going to the left, so these are all the values less than 11. So x is less than 11, and then we should have an equal to because it is a closed circle. For these inequalities down here, we're solving for x. I like to start by moving my x's to the same side first, but you can start it in a different order if you want. If I add 3x to both sides, I'll get 8x plus 4 is less than 3. Then I'll subtract 4, and I'll get 8x is less than -1. Divide by 8, and we get x is less than -1/8. If you want to use a decimal as well, that's fine. So on a graph, I'll put -1/8. We're talking about everything less than -1/8, so we're talking about an open circle at -1/8 and an arrow pointing to the left. In interval notation, this will be -infinity to -1/8 with an open parentheses because it's an open circle. For number 4, we'll have to distribute first. So we'll do 4x plus 4 is less than 2x plus 3. Now I'll move my x's to the same side, so personally I would move the 2x over here. We'll have 2x plus 4 is less than 3. Now I can subtract 4. I'll have 2x is less than -1. Divide by 2, and we'll have x is less than -1/2. Again, if you want to write it as a decimal, that's fine. So on my graph, I'll have a point at -1/2. Again, we're less than, so it'll be an open circle because it's not equal to, and less than will be to the left. So in interval notation, this will be -infinity to -1/2. Parentheses. All right, for number 5, we'll distribute first as well. So we'll distribute here, not to the -1 on the outside because that's only in front of that. So this will be 8x minus 8 minus 1, 6x minus 1. I recommend combining like terms before you continue. So on this side, we'll have 8x minus 9. Now I'll move my x's first, so I'll move my 6x over here. That'll leave me with 2x minus 9 is greater than -1. I'll add 9 to both sides, and that'll give me 2x is greater than 8. Divide by 2, and that'll give me x is greater than 4. So I'll put a little circle at 4. Again, it's open, but now it's x is greater than 4, so we're going this direction. So we're talking about 4 parentheses to infinity. All right, for number 6, we now have a compound inequality. So we're solving for x still, but whenever we do something to one side, we'll have to do it to the other side. So we'll subtract 3 from all 3 parts here. So we'll have 3 is less than x, which is less than 5. This is my solution, and now I just need to graph it. So I want a number at 3 and 5. They'll both be open circles because these are not equal to. But then we'll read them one at a time. So first we'll read this one. This one says x is greater than 3. So this will go this way. And this part here says x is less than 5. So this will go this way. They're pointing towards each other, so we'll connect them together. And when they're connected and you write an interval, we'll just be going from, there should be one interval from 3 to 5, and these are parentheses because of the open circles. Over here, we'll start by adding 5 to both sides. Well, to all 3 sides, we'll get 2 is less than or equal to 2/3 x less than 4. To get rid of the 3, that's dividing by 3, so we'll multiply all 3 parts by 3. That'll get rid of the 3. we'll have 6 is less than or equal to 2x, which is less than 12. And then they're multiplying by 2, so we'll divide everything by 2. And we'll have 3 is less than or equal to x, it's less than 6. So this is my solution. Again, I need to graph this. So I'll put 3 and 6 on here. Closed circle is 3 because of the equal to. Open at 6. And again, we'll read these one at a time. So first I'll read x is greater than or equal to 3. So that'll go this way. And then I'll read this part. X is less than 6. So that'll go this way. They're pointing towards each other, so they'll come together. And when it's one interval like that, it will be 3 to 6 bracket on 3 because of the closed circle. When they're connected, it should only be one interval. All right, for number 8, we'll start by adding 1 to all 3 parts. So we'll have negative 10 is less than 2x is less than or equal to negative 4. Okay, then we'll divide by 2. We'll have negative 5 is less than x is less than or equal to negative 2. This is my solution. I need to graph it, so we'll put an open circle at negative 5 because there's no equal to, a closed circle at negative 2 because there's an equal to. We'll read each of these at the same time. So this one says x is greater than negative 5, and this one says x is less than or equal to negative 2. Oh, sorry, I wrote 5 here. So less than or equal to negative 2. So they'll be pointing towards each other. When they're pointing towards each other, our interval will be from negative 5 to 2, bracket on 2, because of the closed circle. Alrighty. You won't get any of the separated ones or the unions until you solve the absolute value equation. So it should, all of those would be like that. So now let's solve some radical equations and some rational equations. So with radical equations, first you want to isolate the radical. Right now this one's by itself, so to get rid of the radical, we square both sides. On the left, that will leave us with 56 minus x because it undoes the radical, and then we'll have x squared here. Because I have an x squared and an x, I'm going to have to move everything to this side where the x squared is. So I will add x, so I'll have x squared. I'll add x and then subtract 56, and I'll have a 0 over here. If you want to write out the little steps here for that, you can. You'll subtract 56, add x to both sides. Then we're going to factor. So we're looking for two numbers that multiply together to get negative 56, add together to get 1, because there's an invisible 1 here. That'll be x plus 8, x minus 7. Set both of those factors equal to 0. And you'll get x equals negative 8 and x equals 7. But remember, radicals are the ones where you want to check. So you do need to check these answers because one of those will not work. When you check this one, you're going to get an issue. So if you plug in negative 8, you'll get the square root of 56 plus 8, which will be 64. And then you'll get negative 8, and then you'll get 8 equals negative 8, which is a problem. So this one does not work. Whereas when you plug in 7, you'll get the square root of 49 is equal to 7, and you'll get 7 equals 7. All right, and remember, you only have to check with radicals. Okay. So now, when we have a rational equation, first you isolate the thing with the fraction exponent, which that's already isolated here. So then we raise both sides to the power of the denominator. So we'll use the 4 here. That will cancel out the denominator, and we'll have x to the 5th. And then this is a really big number, 243 to the 4th. So you'll have 3, 4, 8, 6, 7, 8, 4, 4, 0, 1. And then remember, we need to do a root to both sides to get rid of the 5. So this will be the 5th root. And do that in your calculator, and you actually get a really nice number. It will just be 81. So that's the answer here. And when you do a 5th root to both sides, you do not need to do plus or minus. It's only when you do a square root, not cube root or a 5th root. Okay, so now number 11. Again, this is a radical equation, so the first thing we do is isolate the radical. So we'll subtract 10 here, and we'll get 10x minus 1 is equal to 3. Now we square both sides to get rid of that radical. That'll make the square root go away, and we'll have 10x minus 1 equals 9. Now this one only has an x, so we just need to solve for x. So we'll add 1, divide by 10, and we'll get x equals 1. Now we should double check these just to make sure. If I plug in 10 plus radical 10 minus 1, I'll get radical 9 equals 13. And this will be 10 plus 3 equals 13, and 13 equals 13. So that does work. Again, you could do this part here in your calculator, that's fine, if you just plug it all in over on this side. All right, let's do another radical equation here. First, we isolate the radical, so we need to subtract the 5 first. We'll have x minus 5 equals the square root of 3x minus 11. We'll square both sides to get rid of the radical. That'll leave us with 3x minus 11 over here. But remember, x minus 5 squared is x minus 5 times x minus 5. So we'll need to multiply that out. It's not just x squared minus 25. So this will be x squared minus 5x, because we're doing x times x times minus 5, negative 5 times x, and negative 5 times negative 5. So minus 5x plus 25 is equal to 3x minus 11. Combine like terms over here, we'll have x squared. Combine these two, we'll have negative 10x plus 25 equals 3x minus 11. We will need to factor, but remember we cannot factor until it equals 0, so we'll move the 3x over and the 11 over. So I'll have x squared minus 13x plus 36 equals 0. Now that it equals 0, I can factor. Two numbers that multiply together to get 36, add together to get negative 13. That'll be minus 9 and minus 4. Set both of those equal to 0. And we get x equals 9 and x equals 4. Now we should check these. So if we check the 9, plug everything on the left into your calculator. So plug 9 in for x, and you're getting 9 on the left for this side. And then for this whole side, if you plug 9 in, you'll also get 9. And then over here, when you plug in 4 on the left, on this side, you'll get 3 times 4 is 12. You're going to get 6. So this will not work. All right, one more radical equation here. These are isolated already, so we just need to square both sides. That will make both the radicals go away. So we'll have 11 minus x equals x minus 7. This is pretty convenient because it's easy to solve. So I'll add my x's to both sides. I'll have 11 equals 2x minus 7. Add 7. Get 18 equals 2x. divide by 2, and we get x equals 9. If you want to double check this one, you can. It will work. You're just going to possibly get you'll just probably get a decimal answer, because you'll have the square root of 2 equals the square root of 2, which is a decimal, but that's still okay. All right, and last one like this. This is a rational, so everything to the rational power is isolated, so we're going to raise both sides to the power of 2, because that's the denominator. That will cancel out the denominator, and we'll have y minus 6 to the third. 125 squared is a pretty big number, but that's okay. Then to get rid of the cube, we're going to cube root both sides, and we'll have y minus 6. The cube root of that, if you type that into your calculator, is 25. You do not have to plus or minus when it's a cube root, only when it's a square root. So then we'll add 6, and we'll get 31. You can check these answers if you want, but you don't have to. All right, let's go on to our absolute values here. So when we solve an absolute value equation, remember we're going to isolate the absolute value first, so we'll add 2 to both sides. Once we have it isolated, we want to make sure it equals a positive number. So this equals 5, which is good. Then we can make our two absolute value equations. One will be x minus 4 equals 5, and one will be x minus 4 equals negative 5. Add 4 to both sides, and we get x equals 9. Add 4 to both sides over here, and we get x equals negative 1. You can check these if you want, but you don't have to. This absolute value is already isolated, so we'll go ahead and make our two equations. Solve. Divide by 2. We get y equals 1. Solve this one. Divide by 2. And we get y equals negative 8. Over here, we need to isolate our absolute value first. To get rid of the 5, it is a positive 5, so you do need to subtract 5 from both sides. But that's going to leave this negative here with the absolute value. So this will stay with the absolute value. It's like a negative 1 in the front. Then to get rid of that, remember it's like a little negative 1 in the front, so you just divide by negative 1. So you have x plus 3 is equal to 1. You can do these steps a couple different ways, but as long as you get the absolute value of x plus 3 equals 1, you're fine. And so then you'll have x plus 3 equals 1, x plus 3 equals negative 1, subtract 3, and you get x equals negative 2, subtract 3, and you get x equals negative 4. On to our absolute value inequalities. These work almost the same way. So again, we're going to subtract 2 to move that over. It's still a positive 2, so you still have to subtract it. That negative stays with the absolute value. And then we need to get rid of this negative 1 in the front because there's a little invisible negative 1 there. So we'll divide both sides by negative 1. But because we divide by a negative, remember that's going to flip the sign because we divided both sides by a negative here. Once your absolute value is isolated, you make sure the number is positive on the other side, and then you make two inequalities. One is 3x plus 4 is less than 12, because we said less than, it will be an and. And then for the second inequality, we'll flip our sign and make our number negative. Then we'll go ahead and solve. So we have x is less than 8/3. If you wrote it as a decimal, that's fine. And again, x is greater than, so we have and x is greater than negative 16 over 3. Again, if you wrote it as a decimal, that's fine. And then we just need to put them on our number line. So we'll have negative 16 over 3 here, 8/3 here. We'll read each one individually. So x is less than 8/3, so open circle going this way. X is greater than negative 16/3, open circle going this way. They're coming together, which should check out because it's an and. And so then our interval will be negative 16/3 to 8/3. All right, this absolute value is already isolated, so now we will just make our two inequalities. This one's 2x minus 1 is less than 5, so that'll be an and again. And then we'll flip the sign and make the number negative for the other side. We're solving. Divide by 2. So we have x is less than 3 and x is greater than negative 2. So we need negative 2 and 3 on here. Read individually. X is less than 3, so open circle at 3 going this way. X is greater than negative 2, open circle going this way. They connect, which should check out with an and. So our interval will be negative 2 to 3. Alrighty, for number 20, already isolated, so we'll make our two inequalities. 3x minus 15 is greater than 3, so this will be an or. Flip our sign, make the 3 negative. We'll add 15 to both sides. Divide by 3. This is an or. Oops, I lost my 15. So add 15 to both sides. Divide by 3. So we have x is less than 4, or x is greater than 6. So we need a 6 and a 4 down here. Open circle on 4. X is less than 4, so this way. X is greater than 6, so this way, which checks out with the or that they're facing opposite directions. And then we need two intervals here, negative infinity to 4, union 6 to infinity. All right, last set here. For this one here, we're going to isolate the absolute value first, so we'll subtract the 5 over. So then we'll have 2x plus 1 divided by 3 is less than or equal to 4. We'll make our two inequalities. So we'll have 2x plus 1 is greater, or divided by 3 is less than or equal to 4. So this will be an and, because that was less than. And then we'll flip our sign for this one. Make the 4 negative. We need to get rid of the 3 first, so they're dividing, so we're going to multiply by 3. To get rid of the 3, so we'll have 2x plus 1 is less than or equal to 12. Subtract 1. Divide by 2. And we'll have x is less than or equal to 11 halves. And over here, same thing, get rid of the 3 by multiplying. So we'll have 2x plus 1 is greater than or equal to negative 12. Subtract 1. Divide by 2. And x is greater than or equal to negative 13 halves. If you wrote it as a decimal, that's fine. So our negative 13 halves will be over here in the negative side. 11 halves over here. X is less than negative, or less than 11 halves, less than or equal to, so close circle this way. X is greater than or equal to, so greater, Equal to is just a circle. Greater than will be this way. So they're pointing towards each other. They'll connect, which makes sense because it's and we'll have brackets here because of the closed circles. And we're done with that one. All right, isolate our absolute value first here. Make our two inequalities less than 5. So this will be an and. Flip our sign, make it negative. I'll subtract 1 first here. The negative stays with the 6. This is a positive 1, that's why we still have to subtract it, but the negative will stay with the 6. Divide by negative 6 here. Oh, sorry. I did some bad math. This should be a 10. 15 minus 5 is 10, not 5. So let's try this again. Subtract our 1 from 10 and you'll get 9. Divide by negative 6. And when you divide by a negative, that's when you have to flip the sign. So we'll have to flip this. And this will be negative 9, 6. And over here, we'll subtract the 1. Again, the 1 is positive. That's why you have to subtract it. The negative stays with the 6x. You can do these different ways, so if you find a different way you like it better, that's fine, as long as you get the same answer. Divide by negative 6. When we do that, we have to flip the sign. So keep in mind for both of these that we flipped it, because we divided by a negative. And that'll be positive 11 over 6 now, because negative 11 divided by negative 6 will become a positive. So we'll put negative 9 over 6 over here and 11 over 6 over here. X is greater than negative 9 over 6. X is less than 11 over 6, so they'll point towards each other, which makes sense with an and. So it'll be negative 9 over 6, 11 over 6. One interval because it's one section on the graph. All right, last one. Already isolated, so we'll make our two inequalities. This is greater than or equal to 4, so this will be an or. Flip the sign, make the 4 negative. We'll multiply both sides by 3 to get rid of the 3. So we'll have x minus 2 greater than or equal to 12. Add 2. X is greater than or equal to 14. Over here, same thing, multiply both sides by 3. X minus 2 is less than or equal to negative 12. Add 2. X is less than or equal to negative 10. This is an or. So we'll put our negative 10 down here, our 14 here. X is greater than or equal to, X is less than or equal to negative 10. So it'll go this way. X is greater than or equal to 14. So it'll go this way, which makes sense with an or. They should be separate. And this, we need two intervals because there's two arrows. So negative infinity to negative 10, bracket, union, 14 to infinity.